In this video, I'd like to introduce the nomenclature of carboxylic acids and nitriles. After watching the video, you should be able to provide IUPAC accepted names for carboxylic acids. That will include structures for acids with common names of formic, lactic, pyruvic, benzoic, and malonic acids. You should be able to provide IUPAC accepted names for nitriles, and there's 4 separate methods that we'll learn for naming nitriles. Adding nitrile to the end of the hydrocarbon name, replacing the ending of a carboxylic acid with O-nitrile, naming it as an alkyl cyanide, or naming it as a cyanosubstituent if a higher priority functional group is present. So let's first look at the nomenclature of carboxylic acids. Carboxylic acids are most often named by replacing the E of the full hydrocarbon name with oic acid. As an example, a 1-carbon carboxylic acid would be based on methane, so it would be methanoic acid. Now it turns out that carboxylic acids have common names to which they are usually referred, and this one has a common name of formic acid. I don't think you'll hear anyone really calling it methanoic acid, but formic acid refers to a 1-carbon acid. So the form tells you that there's 1 carbon present in the carboxylic acid. The carboxylic acids are the highest priority functional group that we have seen to date in nomenclature, and so if there are other functional groups present, they will be lower in priority. So here is an example in which there is an alcohol and a carboxylic acid present in the molecule. If we use substitutive nomenclature, we would name this as a substituted propanoic acid, and there would be a hydroxy on carbon 2. Hydroxypropanoic acid. There's no spaces in the hydroxypropanoic portion of the name. There is a space between the oic and the acid. That is the substitutive name. Again, common names are prevalent for carboxylic acids, and this one is lactic acid. Perhaps you've seen this as the product of glycolysis under anaerobic conditions. It would be a lactate, the anion of the lactic acid in a biological system. And this is the molecule that results in muscle fatigue after too much exercise. This is what causes the pain of acid buildup in the muscles. If lactic acid is oxidized, we can get this compound that has a ketone on carbon 2 instead of a hydroxy group. Aldehydes and ketones, when they are lower priority functional groups, are named as oxo prefixes. So on carbon 2, I have an oxo prefix, and this is a substituted propanoic acid. So that's our substitutive IUPAC name. The common name is pyruvic acid. This is also a product of glycolysis, and this would be under aerobic conditions. If you have a carboxylic acid bonded directly to an aromatic ring, a single ring, it's benzoic acid. Dicarboxylic acids are named by adding dioic acid to the full hydrocarbon name. Here's an example of that. I have a 3-carbon acid, so this would be propane dioic acid. This is also malonic acid as the common name. In a chapter to come, we will talk about malonic esters, in which those H's are replaced with R groups, and we will see things such as the malonic ester synthesis. Moving on to the nomenclature of nitriles. In terms of functional group priorities, it's just above aldehydes and ketones, and it's just below carboxylic acids and all of the other carboxylic acid derivatives. I've already mentioned that there are multiple ways to name nitriles. The first method is to add nitrile to the full hydrocarbon name. When you do this, you want to include the carbon of the nitrile in the root name. For instance, using this method, this would be ethane nitrile. Looking at another example, I would have a bromo substituent off of a butane nitrile. So this would be 3-bromo-butane nitrile. For the second method, we can replace the ic acid or oic acid with O-nitrile. So let's take a look at acetic acid. And rename it as the corresponding nitrile. This one would be acetonitrile. It's also acceptable to name nitriles as alkyl cyanides. So by this method, this would be isopropyl cyanide. Please note that there is a space between the alkyl name and cyanide. Of course, we've already seen method 1 as an option, in which we name this as a hydrocarbon nitrile. So this would be 2-methyl propane nitrile. So either one of those names would be fine for this molecule. If a higher priority functional group is present, then we'll need to name the nitrile as a cyanosubstituent. Carboxylic acids are higher in priority than nitriles. So this would be a propanoic acid, and there is a cyano on carbon 2. So this would be 2-cyanopropanoic acid. I encourage you to pause the video and give this molecule a name. Now hopefully you can see from the previous example that the cyano includes the name of the carbon and the nitrogen. So if we name this as a cyanosubstituent of a carboxylic acid, it is a 3-carbon carboxylic acid, and so this would be 3-cyanopropanoic acid. So the take home here is really that if you use the cyano as a portion of the name, that you do not also include that carbon in the root name. When you're naming as either a cyano or a cyanide, the C of the CN group is accounted for in the cyano or cyanide name. It is not part of the root. So in this video, we've learned how to name carboxylic acids and nitriles.